What's up, guys? I've had to record this twice already. I was having issues with the audio, so I'm just going to speak over this. What you're going to see right now that I'm going to show you is something called Dr. Quantum. And Dr. Quantum is a cartoon that comes from a movie called What the Bleep Do We Know Down the Rabbit Hole? And it's about stuff that nobody really knows. This is the double slit experiment. And because audio can't come through, otherwise I'll get a copyright strike, I'm going to quarterback this for you guys. So I'm going to explain to you exactly what you're seeing. Okay? Okay, good. All right. Hopefully this is the last time. So here he is just explaining what we're going to get into. Ignore the physics in the back. And this is the double slit experiment. You're going to see why it's called the double slit experiment very shortly. So this is a particle. And what they do is they fire it through a single slit. And you'll see a line in the back, which makes sense, right? Because it's going through the hole. Now what they do is they take a particle in two slits and you get two lines. So far makes sense? This makes complete sense, right? Now these are waves. Okay? Waves come through, and in the middle part is where it hits the hardest. That's why it's lightest in the middle. And then it fades around it. So that's what you're looking at right now, is you're looking at the wave. And again, in the middle, where it came through, is the strongest. Now here is where they do two slits for a wave. And the two slits for the wave come out and cancel each other in the middle, and they form something known as an interference pattern. And you can see it on the back of the wall right there. Because the waves bounce off each other, basically, they make this pattern. Okay, so we have the marbles, one line and two line, made two lines and one line. Then we have the interference pattern. Now this is what you're looking at. Yeah, that's basically what he's showing you right now, is what we just went over. So it's waves and particles, guys. That's very important. We're going to get into that a little bit later. So now we're going to the quantum world. We're going into the very tiny world. And they were using electrons to shoot this through this same double slit experiment. So they're firing the electrons as a beam, and the particles are hitting the back of the wall, making a single line through one slit. Makes sense? Now they got two slits, and they do the same thing, and it forms an interference pattern. Well, that's weird and wild, right? Why would it do that? You would think it would be just like the other particles. So what they did is they fired them through there, and it continued to make the patterns, and they shot them one at a time, and one at a time, it still made the same pattern. So what he's trying to explain to you right now, which I'm going to explain to you right now, is they shoot it one at a time, right? We just went over this. And as they shoot it one at a time, it still forms an interference pattern after about an hour or so. So they were confused. They were like, what is going on here? Like, how does this make sense? The particle actually split, went through both, came back together, and shot to the wall. It also did not go through the hole. It went through one of the holes. It went through the other hole. It existed in a wave of patterns, a superposition. So what they then did to try and make sense of this whole thing was they put an observer, an observational thing, to actually physically see which one it went through. When they did this at the quantum level, they found that the electron went back to being a particle and made two lines. The observation is key, guys. This is consciousness. And this is what happened. So it made the wave pattern without observation, and with the wave pattern with observation, or the electrons with the observation, it made two. Yeah. So where we're at right now is that the very act of observing changed it from a wave to a particle to something that could be measured. Now, this is significant. This is a crazy significant story because it has implications on a grander scale, which we're going to go into right now. So now that I went over that with you, I hope I explained it well for you guys. What you guys have to understand is this. This exists, right? This exists on a physical plane, right? However, if I put this down and I turn around and there's no one else in the room and there's no animals and nothing, it exists in what's called superposition. It's the act of observing that changes things. It's the act of observing. And if you think about it, what is this made out of? It's matter, right? You have a proton, an electron, a proton, a neutron, and then it surrounds by the electron, but it's all 99% empty space. More than that, actually. What remains is not actually empty space at all. It's known as eigenvalues in a wave equation, which is the mathematical probability of actually observing something. So, what you guys have to understand is that consciousness dictates the material thing. What we think is matter, it's not actually matter at all. It exists as waves and it exists as particles. Also, when you think you're touching something, you're not actually physically touching something. The electrons from this desk, the electrons from my hands, repel at 10 to the negative 8th power. You are never physically actually touching something. The electrons are always repelling. So what else does that mean? Well, let's talk about Schroedinger's cat real quick. So it's a very similar thing. You have a cat in a box, and with the cat in the box, you have a little radioactive isotope. And you put it in the box and you close the box. And you have two options that are going to happen. One, the cat is not going to do anything with it, and then you're going to open the box, it's going to jump out and do whatever. The other thing is it's going to smack the radioactive isotope in the box, releasing it, thus killing it. And then you open the box and it's going to be a dead cat. Stephen Hawking famously said, when I hear about Schrodinger's cat, I reach for my gun. He had a lot of work to do, though. Stephen Hawking. I read a brief history of time, but that's a whole different story. So what you guys need to understand is that when the box is closed, is the cat alive or dead? And just like I showed you that it's a wave of opportunities, a wave of options, the cat is both alive and dead until you collapse the wave function. In fact, if you guys are interested in this, there's a great book called The Flicker Men. And it's a story about a quantum physicist who's on his last leg in the industry. They say publish or perish. That's a phrase that they use in academia, which then ties into, obviously, peer review, which is awful. It's expensive. It takes a long time, and it's very biased. But whatever. So in The Flicker Men, this man recreates the double slit experiment. But what he finds out is that animals cannot collapse the wave function. So this ties into the soul, because it's consciousness. It is consciousness that collapses this, that makes this from a piece of material to a wave. I hope this makes sense, guys. Things exist in multiple positions. In fact, they have measured things that they haven't viewed that have been in 7 different locations at once. So I know it's a wild concept. We'll get into entanglement eventually, but I just wanted you to see that. So I hope this makes sense to you guys. If it didn't, please leave comments and I'll do a follow-up video. All right.